Welcome everyone. We would like to present our experimental work about ornamentation on stone battle axes. The objects of our interest were specifically late Neolithic axes found in southern Poland and attributed to the corded ware culture. The decoration on these types of tools consists of linear patterns that resemble string binding. They are extremely rare, especially given the relatively large number of battle axe finds. Our experiment was conducted following microscopic observations of two decorated battle axes. Our goal was to replicate the ornament and thus learn how it could have been made, and to create a reference base of traces related to its production. The first of our case studies were found in the vicinity of Kurządkowice village in Lower Silesia, Poland. It's a loose find of a Ślęża-type battle axe. This group of artifacts is characterized by clearly distinguishable parts of the tool in form of a horseshoe-shaped butt, widened central part with a hole, and a blade that slopes from one side. Most prominently, they were made from a serpentinite, the outcrops of which are located around the Ślęża massif. During the microscopic examination, we were able to distinguish traces of different phases of its production, including the flaking phase, different grinding activities, and traces of drilling. What might be important is that the battle axe was used for chopping activity, and the cutting edge was repaired and maintained during its use. The ornament in question is placed in the butt of a tool. It consists of 7 lines that go fully around the bottom part and both sides of an artifact. Apart from that, 2 additional lines start from the lateral sides but end prematurely. Lines are deep and wide with rounded edges and U-shaped bottom parts. Inspecting lines more closely, we can see numerous grooves and scratches placed near the main line, indicating the tool's departure from its path. At the bottom and inner walls of the line, we can also see scratches left by repeated movement of the incising tool. Despite this, the ornament is well crafted and wasn't worn off over the use life of a tool. That will not be the case with the ornament of the second artifact. The battle axe from site Budziszów Wielki 2 and 3 is part of a set of 4, found together in a shallow pit during preliminary rescue excavation preceding the modernization of a highway in Lower Silesia. The artifact itself is made from diabase. Its form relates to the battle axes that appear in the late Neolithic period in southwestern Poland. In addition to abundant manufacturing traces, it bears marks of heavy, long use and multiple repair phases that include, among others, cutting-edge resharpening and possible traces of retooling. In this case, decoration is not restrained to one part of a tool, and lines go around all of its sides. There are 6 parallel lines, one of which spirals and re-enters the surfaces a few times. Lines vary in depth and width during their course. They often double, split, or are composed of many smaller tracks, in some places disappearing to appear later in different positions. They often don't connect, especially at the intersections of 2 surfaces. It also appears that after the ornament was produced, it was not cared for or maintained. The lines were worn away by subsequent surface grinding and repair phases. Carried out microscopic observations left us with unanswered questions, which we tried to solve experimentally. We focused mainly on the technique of decorating, taking into account the variable tools and type of activities. We were also interested in reproducing the sequence of activities performed as part of the decoration. And as we also wanted to create a reference collection, we decided on a less controlled course of an experiment to possibly learn how different mistakes during work are made. Preparations for our experiment began with the production of sandstone grinding slabs. As we only had large blocks of raw materials, we first cut them with a masonry saw and then roughen up the working surface by packing using hard hammers. Shaping of a serpentinite preforms, on the surface of which we would incise the lines of ornament, was made by using hard hammer percussion. Knapping of a serpentinite nodule is slightly different from flint because of more chaotically dispersed minerals inside the rock. Apart from all the principles we knew from flint knapping, we had to find the linearity of minerals and exploit it, knapping alongside it. Even then, the ratio of hinges and force of blow going not the way we wanted was quite high. As the next step, we prepared the tools with which we would be making lines of ornaments. We utilized flint and serpentinite to make flakes, retouched flakes, and burins. Granite and sandstone were used to prepare only flakes and burins, due to their structure being composed of large grains of minerals and crumbling rather than retouching. Each tool's working surface was documented and detailed before the experiment. Then we proceeded with wet grinding of our serpentinite preforms. Fine sand was added as an abrasive material. Grinding one side of a tool took us from 24 minutes to 114 minutes to finish, depending on the curvature of the surface and the number of deep negatives from the shaping phase. With all of the things prepared, we could at last start incising the lines of ornament onto the preforms. Each line was made with a different tool from a different type of raw material. Two experimenters worked simultaneously on their respective preforms, and the progress of the experiment has been documented during the work. The course of the work itself brought us a lot of information regarding the technique and use of various tools. General remarks that apply to the work regardless of the type of tool are that it's easier to guide the line of ornament on a grounded surface, especially if it's not completely flat. The tools catch rounded surfaces more easily. On rough surfaces, without grinding, the working surface of a tool jumps over irregularities, and it is difficult to maintain a single line path. Regularity of working edges of tools also helps in keeping a straight line of ornament. The preferred technique that we resorted to was to slowly, repeatedly incise the surface with one of the tips of the tool, and when the line of ornament was prepared, we used two-directional cutting sewing motion with the entire edge of a tool to deepen it. Without the previously incised line, the tool creates many cracks and scratches as it ventures all over the surface. Characterizing each tool individually, we can say that working with those made of flint was the easiest. Applying retouch made it easier to cut the surface initially, which helped to keep the line straight, but when the groove was deeper, it started to create additional surfaces, steps on the interior walls of the ornament. The burins that we utilized made really thin lines and had trouble traveling through the rough surfaces. The cause of this may be attributed to too small parameters to have enough penetrating force. Working with granite flakes and burins depended significantly on the good location of hard minerals along the working surfaces. Both tools of one experimenter were quickly rounded and work couldn't be continued further, while the other experimenter finished the work. Granite tools notably held a lower penetrating force than those of flint, especially on flat surfaces. Lines were very wide and more grated than cut due to the wide cutting edge. Tools made of serpentinite fared the worst. Working surfaces quickly crumbled and rounded down. In less than 20 minutes, without further developments, we abandoned our efforts. Burins notably couldn't even cut the surface and only erased previous grinding traces. Unless a large number of them were utilized, we don't think that they could have been used to make the ornament. Lastly, working surfaces made of sandstone were alternately chipping away and stabilizing, which allowed for the continued work to be carried out. Lines made with these tools were wide and more grated than cut, as was the case with granite, but penetration was easier. The structure of the raw material, composed of various macroscopic grains, caused many lines of abrasion and scratches to appear in and around the main line. Carried out microscopic observations of our experimental work allowed us to further characterization of lines. The ones made with flint tools were deep and wide, often accompanied by many grooves and scratches alongside the main line path. Scratches also appeared in the interior of the line, on its bottom surface, and the side walls. Many steps on the side walls were also visible, especially on the lines made with retouched tools. Lines are often composed of many smaller tracks and don't connect on the intersections of the surfaces. Lines made with granite tools are shallow and wide, with a multitude of scratches accompanying the main line and inside of it. Sometimes the path of the line is composed only of them, with no recess on the surface. On the rough parts of the preform, decoration consists only of a linear belt of abrasion with scratches. The most notable trait regarding the use of serpentinite tools is visible lines of metallic polish at the bottom of the line and at the places where the tool ventured over the surface. Lines often consist of short indentations on the surface that later turn into multiple scratches when the tool gets rounded. Traces made by sandstone tools are a combination of the before mentioned traits of granite and serpentinite tools. They are wide and deeper than those made with granite, but otherwise the same, with the addition of metallic lines of polish, similar to those made with serpentinite, although in this case produced by grains of quartz being chipped away. To conclude, we are closest to the assumption that flint tools were used to produce the ornament on the artifacts. This is evidenced by similar traces of manufacture obtained during our experiment. The traces we obtained experimentally most closely matched those found on the battle axe from Budziszów Wielki. The one from Kurządkowice shows a greater degree of care in its production. Our preferred and most efficient way of producing the lines of ornament was to first make the incisions with the tip of the tool and then work in a two-directional cutting-sewing motion using the entire length of the cutting edge once the ornament line was deep enough. Grinding the surface on which we want to place the ornament helps to maintain the single main line of the ornament, and mistakes in form of multiple lines and occurrences of grooves and scratches beyond its main course may come from the jumping of a working tool on the surface of the half product. The reason for this might be the curved working surfaces of tools or insufficient skill and patience in guiding the line. Thank you for your attention.